If you haven't seen my data structures and algorithms course in Python, the link is up the top right. Welcome to my channel. In this episode, I'll be teaching you another HackerRank problem around data structures and algorithms. This one is a very easy one, but it's a fundamentally important one for you to understand a lot of the remainder of HackerRank Python for data structures and algorithms, or in short, DSA. Let's jump into this one. If you haven't yet subscribed to my channel, please go ahead and hit the like button and share this channel with your friends. If you're a frequent visitor to my channel, you would know that I have a Jupyter lab in black that helps me decipher the problem and explain what is really going on. And in white, I have the actual problem from HackerRank. This one is called print the elements of a linked list. I teach using drawings, diagrams, and graphs. A lot of people seem to enjoy them, so hopefully this one will be useful to you. This exercise focuses on traversing a linked list. I have a video that explains what a linked list is, what list nodes are. I will explain them very shortly in here, but if you're keen to understand a bit deeper and forever, the link is up the top right. You are given a pointer to the head. I'll tell you what it means. Of a linked list, the task is to point to the data of each node, one per line. If the head pointer is null, indicating the list is empty, print nothing. So let me show you what type of information we will be getting. We will be getting a number in the very first line. That defines how many nodes there are. So in this case, we will have two nodes. The first one will be 16, which is the first data value. And the next one is 13, which is the second data value. The sample output is expected to print 16 and 13. I will try to make your life easier by explaining what type of code we already have in HackerRank. If you look at HackerRank, there is a lot of comments in green up the top. It is for you to understand what is going on. But if I scroll down, this is the function that we are asked to write. First things first, I'll copy that. I'll bring it over and I'll call this step 2. Step 2 is that I will have to complete this function. I will put the word pass there because then if I run this, I will not get any errors. If I delete it and if I run it, you will see that I will get an error. The word pass allows you to run it without running into issues. But step number one is getting the inputs. Because as I said, we will be getting the input from the user, then we will do whatever that we're going to be doing. The inputs will be coming from these lines. Let me copy those. I don't really need the last one. Let me copy the inputs, bring them up here. All right, I'll have to get rid of the indentation. Now that I've pasted this code, you may ask, hey, what is this? This first line mimics this first entrance. So that will accept the number of tests that we will be running. This one has been defined within HackerRank. I'll show you where it is defined. For now, you can just ignore it. And this one will run n times. So if you set n equals 2 here, that for loop will run 2 times, and it will accept number 16, and it will accept number 13, and then that will end. I will run this, and I will enter number 2, because I'm trying to mimic what we have here. I'll press enter, and something funny will happen. You will see that I'll get an error saying that, hey, Amir, we don't really know what is singly linked list. Where, fair enough. I never told you what exactly this is. If you come to HackerRank, there is this line up the top here. If you drop it down, you will see that there is a bit of code here, that this singly linked list node and the singly linked list, they have been defined here. All I need to do now is to copy all of this and open a new cell up the top and paste them here. I will run them, and look, that's a bigger question what exactly it is. So I will just hide it so that it has been run and we have it available. And if I run this again, you will see that this time I will not get an error. So import number 2, and then import 16, and then import 13, not 14. If you want to understand what that code is, I really encourage you to watch my video on linked lists and the list nodes. But for now, we have all the inputs. Our job is to perform step 2. Now, you may ask, okay, look, what exactly do we need to do? What is the operation? The operation is pretty simple, but it can be a bit confusing. Let me just get some black real estate and open this up so that I can start drawing. I'll activate my drawing. So what exactly are linked lists? A linked list is comprised of multiple list nodes. Now you may ask, hey, what is list nodes? That's exactly where we're getting at. A list node, I'm just going to draw it a bit large. A list node is like a container, like an empty container, for now empty, that has got two parts. One is the value that sits inside the list node, and one is the pointer that points to the next value. This is a bit different to our normal or traditional lists in Python, where we have in the traditional Python list, we have all of them predefined. So if you say I have a list of 5 fruit, you will have the 5 placeholders already defined. And this will be index 0, index 1, index 2, index 3, and index 4. it already takes all a slot in the memory for each of these values. Whereas in list nodes, you are not really predefining what it is going to look like. You say, hey, take the first one and the pointer for it. The first one might be number 16, and then it will have a pointer that points to the next value, which is 13, and that will have a pointer that will point to the next value that will also keep continuing. But in case after number 13 there isn't anything, it will point to none, which means that it's the end of a list node. So if I clear the screen, because now it is important for you to understand what we're talking about. We are talking about a list node is a container with some value and some pointer. You may ask, hey, Amir, in a traditional list with 5, for example, values in it, like 5, 4, 3, 2, and 1, it is so easy for you to find, for example, value 4. If you want to find this, and if this is called my list, right, all you have to do is say my list sitting at index 1 equals 4, right? Because we are playing with indices. This is 0, this is 1, this is 2, this is 3, and this is 4. We're playing with indices. But in this case, in a list node, we don't have that luxury. The way we find information is by looking at the value, dot value, and dot pointer. This is how we find information. Let me now just specifically talk about list nodes or linked lists. And just for your information, linked list is a collection of list nodes. So it's like the parent. You may have something like this. You start with a head is the beginning of your linked list. Then the head will point to some value, which is 16. That will point to the next value, which is 13, and that will point to none. This is your linked list in this very example. Now, if you want to find this information, or if you want to traverse from here to there, if you want to travel in that direction, this is what you have to do. Each one of these nodes, so if I consider this a node, has got 2 attributes. As I said, it has a value, or sometimes they call it data, depends on what the class calls it, and it has a pointer, which normally is called next. So you can say, hey, Python, I want you to print, so easy, head.data. If there is any value in here, it will be printed. And also you can say, hey, I want you to print head.next. In this case, the next to the head is number 16. So most probably this will print number 16. Let me show you in Python. For me to be able to show this to you, I will open this mystery code from HackerRank, and I will just copy this first class because this is very important. This first class is literally how a node is defined. You will see that it is a class called singly linked list node. As you can see, it has got some node data, which can be anything. It can default to 0. And then this node data goes into the data attribute of the self. And the next is set to be none because this is a singly linked list node. We are saying, hey, this is a node by itself, and it points to nothing because we want it to be by itself. If you wanted this to be not a singly linked list node, if you wanted this to be linked list node, what you would do then, you would define a next value in here, and then you would assign that next value into the self.next. But just make sure this next value defaults to none, just in case you want to make it a single linked list. So this is good now. What I want to do right now, I will call this class, right? I'm just going to create the first node, which has got number 16. All I want to feed to it, I'll say I've got number 16. You can see that I created a linked list node. And if I save it on first node, I will just save it on first node. And I will show you that here, the data attribute is actually 16. So I have been able to store the value, as I said. But there is another attribute, which is the next attribute or the pointer. So if I ask for next, it says, there isn't anything because it's not going to print anything. But if I were to say, hey, the next value is 13, I'm creating the pointer, right? And if I run this, and if I run first node.next, you will see that next is number 13 now. So in graphical terms, what happened in here, in this one, I said, there is a node that I'm asking you to create, put number 16 there, and I want you to point to number 13. Whether this one has been established, well, no, it hasn't because this one is still none. I will go ahead and I will create another one. Let me show it to you. If I create another one and I call it second node, right? And I will put number 13 there and point to none, which means that this is the end of it. If I show you second node dot data or value, depending on how you define your class, we'll see that it's just number 13. And when I look at the next is nothing because it comes to the end. Now, hopefully this makes sense. All I need to do now is to define a function, which is called print linked list, that does exactly this. I will create some empty spaces here so that you don't really get confused. We will be getting the head of the linked list. Again, in graphical terms, we will be getting a head, and our job is to find a pointer to number 16. In this example, different examples might vary, and then number 13, and then to none. So this is what we're gonna get. This is where we're starting. So we need to point to the next, and then set the value, and then point to the next, set the value, which is gonna happen by pointing to the next anyways, and then point to none to get out of this linked list. What I'm gonna do, I'm just gonna create a new variable called current, and I'm gonna put the head inside the current. You may ask, why are you doing it? Here is the reason. When I have this linked list, right, like that, that goes to none, which is the end of it, and it starts with the head, right? And I've got number 16 here, number 13 here. I need something, maybe something like a plate that moves over time. It is first set here, this plate, then it travels to this, then it travels to the next one, then it travels to the next one. Think of it like a treasure hunt. So you've got some treasure here, which is a lot of gold, and then you have the amount of gold and you have the address to the next point. There's more gold in here, you find that gold, you know how much it is, and then you move to the next one. There is some gold in here, you find it, and then you move to the next one, and there is no gold in here. I am going to use this current to do this move. So current comes here, then it moves here, then it moves here, then it moves here. That's why I'm bringing something called current. I don't want to move head, I don't want to move 16, I don't want to move 13, and I don't want to move none. All I want to move is current, current, and current. That's what I'm doing here. While current is not none, I am making sure that when I get to the end, this while loop just ends. So I'm saying while you haven't seen none, because if you see none, that's the end of it. Break and your job is done. Before that, what I'm going to ask you to do is print that data for the current, which means how much gold you found in the current as you are moving over the current, how much gold have you found or what values you have done. That's going to do the printing. And once I have done that, now I need to point to the next one. And this is very important. Let me tell you what is happening here right quickly. So we are starting from the head, that's this part. And then we're pointing to the next, not yet, wait, but current is here. Is current none? No, it's not none. So next bit will happen. The current dot data will print here because that's the statement that we're saying. Once we have done that, we need to move the current to the next bit. So now current goes from here to here because it will have to travel. For that travel to happen, I'll show you what we have to do. For that travel to happen, I will say, hey, move current to the next of the current. And this is very important. With this very line, when I have the head, I will move it to the next value, which is 16. And when I'm done by 16, I will move to 13. When I'm done by that, I will go to none. Simply using this statement. So hopefully this makes sense. What I will do now, I will copy all of this. Wait, we have to return. No, we don't really have to return because we are printing anyways. So let me copy that and I'll bring this to HackerRank. I'll close this extra code base. I will print it in place of this one. And I will run the code. Keep my fingers crossed. This test case ran successfully. Let's submit the code and see if all test cases run. Yep, that was all successful. All right, thank you for watching. I really hope that you enjoyed this video. I take a lot of time to explain and draw. I know that makes my videos a bit longer, but I'm just making sure you just watch it once and it makes sense for the rest of your life, hopefully. But if you ever need to come back to the video, please make sure you watch it again and again. And maybe you start drawing it as well, because if you start drawing and then making some code out of your drawing, it will make more sense. Let me know if you have any questions, and if you haven't already subscribed, please go ahead. That really helps my channel.